And the recording. Welcome everyone to this week's IPLD Dev Sync meeting. It's October 28th, 2019. As every week, we go through the stuff that we've done last week, and then we discuss any open items we might have. I start with myself. So I worked on getting IPLD, Rust IPLD work on Serde, and so the sad news is it looks like we can't do Serde because it would need an upstream change. And although the author of CBOR, so the Serde CBOR stuff is in favor of it, the maintainer is not. So I've linked the comment, I think, in the notes, and it's, yeah, it looks like it's not going to happen. I've posed another comment, so I'm still fighting for it, but it looks like it won't happen. Yeah, I totally don't agree with this decision, but there's not much I can do, I guess. So for now, I would probably just, so there is already a Rust IPLD implementation by someone else, which is not using Serde, and I probably just use this for now, so we can just keep going and then, see what the future brings. But that's, kind of unexpected. So I expected I can convince the maintainer, but I can't. But we'll see.
This is the kind of answer that we would give if someone showed up saying, I want unsigned integers in this format.
Yes.
We would copy and paste that text.
Yes, yeah. But yes, I agree. So basically, I also told him, I totally agree that if you have a library, you don't accept, like if someone comes in and says, I want to do X, Y, you totally don't have to do it. But in this case, it's really that there is basically an agreed upon hack to add tags to Serde. And this is basically what I did for the CBOR stuff. And then this is already implemented in TOML and in message pack. So basically 3 different authors used the agreed upon hack to work around it. And I think that's evidence enough to say, okay, perhaps, that's something that should go upstream. And this is what I was hoping for. But yeah, we'll see. Yes, so that's the current state. I keep you updated if anything changes, but I don't really have any, I don't see big chances that it might change. But there's also good news because totally different thing. Like a few months ago, I was working on the stack prototype on the stack spec geo specification, and I found out that they are doing something with checksums, and they wanted to basically have key value pairs with the hash they are using and then the checksum. And I said, well, you could use multi-hash for it. And they said, great idea, that's what we're going to do. So I volunteered to write quickly a spec for them to use multi-hash. It's digits and extension. And the good news is, so this is a specification which is currently done by independent people, but it will go to the OGC. So the OGC is the major standards body for geostandards, and often also OGC standards become ISO standards. So it basically means, I think it's good to see basically multi-hash getting into like this kind of circles and see, a bit of adoption of it. So that's pretty cool. That's all I have for this week. Rod.
Steven, you are super not muted, and you should be super muted. Thank you.
I am so sorry.
Rod, I think you're the next one in the doc order.
I'm the next one. Sorry, I'm just just doing the morning thing of catching up and, oh, got to do that. Oops. One of my items. So the two things, like not huge this week really, but user-facing schema docs. I really want to get something that is that makes schemas grokkable by people outside of this group, even outside of the PL engineering space. That's just been an itch that's been needing to be scratched. So currently working through that. I've got introductory material. Like the material that I've got up so far is, okay, I've shown up at this thing. What is it? And then this would help you get that in your head. What is this thing? And then it's I have a version on my machine that is restructuring a little bit of the additional content to guide through more advanced materials. And that's what else I'll be doing this week is linking in that and then making a consistent structure so that you could treat that schemas directory as a tutorial to get right up to speed with it and understand it, so that we're just not in an echo chamber, and hopefully other people will show up and critique our work with some understanding of what we're doing, and then maybe even start to use it. So that's my big thing really that I'm focusing on right now. The other thing was the Zcash. No, it's JS IPLD Zcash is busted because the upstream decoder, basically the JavaScript implementations have been abandoned because they were all just forks of Bitcoin with some hacks to make it work for Zcash, and no one's really kept them up to date or maintained. So that's left our Zcash DAG thing, whatever it is. No, it's not DAG. It's Zcash codec for IPLD without a backing implementation, because the one that we're using now has a security vulnerability in one of its dependencies and it's not getting updated, and then that flows through to IPFS. So the IPFS needs to make this optional because it's something that doesn't need to ship to people mostly, unless they really want to use Zcash. But I wrote an implementation a while back, a block decoder, and I got that hooked up last week so that it replaces what's there. And does it have any dependencies? I don't even know if it's got any dependencies. So there's not any risk there of it getting out of date and having dependency security problems. So that's in pull request process, but looks like it's close to getting done. I pushed my branch up just now, Volker. That's what I was doing when I was muted, because you commented that my code wasn't there, even though I said there were updates. So it's there now. That's me.
All right, Eric's next.
Whew. Well, I've had a fun week again, as the last couple of weeks have been. I have just learned so many things about the Go compiler and about how performance works. So a couple pieces of small good news in case we have anybody else try to join us on this. I've learned a bunch of new things about getting the Go compiler to tell me very clearly how it feels. So there's like this one GC flags incantation that I discovered this week that's in the doc. I don't know how I ever lived without it before. Oh my gosh, it is so useful. It's also wildly undocumented. So GC flags -m gives you some short information about what the compiler thinks about escape analysis and where memory allocation should go, like heap or stack and so on. And GC flags, quote it, m again, does something completely different. Well, okay, no, it does the same thing, but it does it with enough information to actually be useful. The single M gives you like, it just says a bunch of things that are facts, but it doesn't give you any understanding of how the compiler came to these conclusions. So I've tried to use this before ages ago, and I think it's basically useless. And 2Ms gives you like this logical tree of when and where and how the compiler decided something failed escape analysis. And so this is actually really, really useful. So I learned a lot of things about the compiler and the memory model this week. And Also found some good documentation that I should compile links to about internal pointers and how the GC regards those. And all of this is useful because I've still been trying to figure out what the shape of the code is that CodeGen should emit, and how the presence of pointers throughout the structure trees will affect the performance of the system overall. And so now with some of this new understanding, I think I can say pretty confidently that as a baseline, yes, we want to use embedded structs most of the time, because that's going to allow us to amortize down the number of distinct memory allocations that we use. So, I mean, that was kind of known. But I've learned a couple more things on top of that, which make the whole thing work much smoother. Despite the fact we want to use embedded structs, so not pointers, most of the time, we actually do want to use pointer receivers and lots of pointers in method calls, because now that I have a little better understanding of escape analysis from those extra flags, it turns out that putting a bunch of pointers in the method signatures doesn't necessarily mean that those things are going to be shifted to the heap. It actually means that the compiler just has a lot more freedom to decide whether or not it wants to shift things around. So if you get lots of methods that, even if things fail escape analysis in the leaf methods, if those methods can be inlined, especially, for example, then it might turn out that in the context where they're used, all of that stuff never escapes. And then none of it actually goes to the heap. And then it's actually really fast, even though you think there's pointers everywhere. And it doesn't necessarily cause internal allocations. Leaning heavily on the internal pointers semantics also means we can have fewer allocations than I thought. So some of my worst case imaginings last week were just wrong, I'm happy to report. So some of the best abstraction ideas I've come up with now is lots of embedded structs, and doing kind of a similar thing on the node builder side. If we have a node builder implementation that actually has a bunch of reserved space inside of it for the node builder types that we know we'll need for the children, then we can have, the node builder for one struct can, when it's asked for the node builder for the member types inside of it, it can just return a subsection of its existing memory, and then that turns into an internal pointer. So there's no more allocations and the same kind of amortization stuff. And if we do that tree of the node builder stuff sort of separately, and then we have the inline structs for the actual nodes, and those just separately, they're returning lots of internal pointers to each other, and the node builders need lots of internal pointers over to the node tree that you're constructing. But that can amortize down to basically one huge alloc instead of being a fractal of allocs throughout the whole tree. So that's pretty good news. That design is probably roughly the direction that I'm going to go now. But it's still not perfect. And I think I can just about prove that it's not perfect, because it turns out a lot of the, I don't know if I want to just read this whole thing aloud. I would probably have some more writing to do about like what exactly the limits as engineering time approaches infinity are here. But I think basically it turns out there's still a lot of trade-offs where, for the most part, we want to embed structures and not use pointers in order to amortize down the alloc count. That much we already knew. But then when we start looking at the ways in which people might use the data structures that we've unfolded into trees, if somebody wants to reshuffle around a bunch of the interior of a tree, then they probably start to wish that there were pointers around again in whatever specific parts of the tree they're reshuffling, because we don't want pointers everywhere, and we failed at amortizing allocs. But we do want pointers wherever you're about to do a shuffle, right? And so it pretty much turns out that wherever you want the pointers to be is determined by the transformations that you're about to do. But this isn't actually information that we can use in the way that we're designing our code generation right now. We're just designing code gen that spits out helpers to do a bunch of tree manipulation in general. And if we don't know exactly the parts of the tree that the user is about to write further code to manipulate, we just don't have that information at the right point in our pipeline in order to use it. I think the most optimal solution, if we totally ignored our own development time and we just had like 1,000,000 years to go tinker in a corner, is we would produce, hang on, a whole new programming language. Rod's muting, but he is laughing, and he should be. Yeah. We would produce a whole new programming language, and probably something that's built on like the category theory, recursion schemes, morphisms sort of stuff, kata hyla hista who. And if we had a programming language like that, then we could determine where we want all the pointers and stuff to be able to do the optimal shuffles that exactly match the actual logic that we want to perform. But that programming language doesn't exist right now, so we probably don't want to build it. So that's frustrating, but I guess I appreciate having this information available now, because now we can definitely know that whatever solutions we pick are going to be compromises. And I guess that at least makes me a lot more confident that we can move forward with said compromises. So, yeah, fun. One other piece of good news, Hannah started using some of the CodeGen stuff to do some work and filled in a bunch more of stuff for like cranking out integer types and stuff. And so we have a little bit of usage exercise there to form a new like feedback loop to make sure we're not screwing up. And that's really exciting. That's it. That was my week. Bless you. Still laughing?
No, I am muted to cough, apparently. So I was thinking, somebody without much background in what we're doing, listening into this, might think, that sounds like some really intense premature optimization, getting right and down into that level for something that doesn't even do anything yet. So to clarify, the work you're doing on understanding the implications of various methods of implementing this thing has direct flow-on effects to the API. So what you're doing now is informing what we present to the user and essentially lock in. Is that correct?
A little bit more than I would like. It's determining where pointers are ending up in all of the maybe types and a bunch of stuff like that. And those are unfortunately things that do leak all the way through to the user-facing API. I wish there was a way to make them not do that, but there is not. Side note, one of the other things I considered is hiding another whole set of stuff under interfaces in the Go code, and then being able to switch out more of where pointers are and are not. But it turns out if you do this, then you lose the ability for the compiler to inline a bunch of methods, and I'm fairly certain that would, in the details, turn out to be a huge mistake. So, putting that aside, the other place it shows up is, oh, right. So I was kind of frustrated to discover this one, but I'm seriously considering an alternative to the node builder abstraction, because the node builder abstraction kind of builds stuff up from the inside. So you build a thing and then you wrap it around and then just keep going out. And that is the opposite of what I want if I'm trying to do my memory allocation in one hunk first and then fill it in as I go. They're completely opposed directions of flow. Ouch.
Right. Does Go not have RVO? Or return value optimization? It's like, if I call something that returns a value, it should be able to just put that directly into the destination without having to do any funky business.
I don't know if that. So the question with most kinds of advanced optimizations is how many other optimizations can it stack with at the same time? Or like how many layers of indirection can I put in between point A and point B and have the compiler still find that that optimization works? So I don't know. Maybe some research is.
Yeah,
like,
I think it's guaranteed in most cases in I think this is guaranteed in most places in C++. I think Rust does as well, but I'm not entirely sure. It is a problem, or it has historically been a problem for boxing in Rust, because like if I call something, ask it to return something, and then I try passing something else and then allocate something, then you end up with a problem where like you create the allocation after you created the thing. So Rust has to actually move or allocate and then move into the allocated spot. So like if I could set it into like some location, it should just work magically, I would hope. But maybe not.
Yeah, it's probably worth exploring. I guess what I would be worried about is, so one of the purposes of having the node builder abstraction is so that we can connect the codecs to this node builder thing. And that's how we like trivially make the codecs, like be able to use 19 different codecs as plugins over the same data structure, even though the data structure might be code generated and be super specialized, right? And so most of the time when we're creating some new values, they're just getting put into the abstraction of the node builder again. And because there's a bunch of interface going on there, the amount of inlining that's available is minimal to none. And so at that point, like, I don't know if RVO is capable of working under those conditions. Like maybe it is.
Actually, I don't think Go has RVO anyways. Just a quick search did not show me anything.
It's also always possible they call it something weird.
I mean, they could implement it, but they don't.
Concepts lately.
Yeah, but I was looking. Okay, I was searching and I saw some people indicating that it didn't have it. I don't know how old those answers are though, so it's hard to tell.
If you want to come Splunk performance with me, I'm kind of having a ball over here. Like I'm starting to just write shell scripts around the compiler to like dump some benchmark and then be like, does this have the feature? Yes or no? And then that's one way to get hard answers about this stuff.
I'd love to. This week is kind of, yeah, I don't have.
Well, I might try to bother you next week or so just for fun. Anyway, aside from, yeah, I don't know, getting closer.
All right. I guess Steven doesn't have any update, I guess. So what else do we have? I forgot to mention that on Friday I will be off because it's a public holiday here. Yeah, and there is other notes at the bottom. Yeah, so Eric asked if I could do selector stuff without the serialization stuff. I guess yes. So okay, yeah. So as this serialization stuff is complicated, as I've mentioned, but I guess like just getting it work somehow shouldn't be a big deal. Like basically getting the data somehow into CBOR and back shouldn't be a big deal. The point was I wanted to use Serde, but if I don't use it, it shouldn't be like, yeah, much work. So anyway, so basically what I'm saying is the serialization stuff wouldn't and shouldn't be a blocker on any other work, I guess. So yeah. Yeah. But I actually haven't planned. Okay, so yeah, so I haven't planned in much detail my next steps, but the idea was to, before diving into the selectors probably is to look like, so the plan is to look into the Rust ecosystem, what we currently have and what's out there, like the whole multi-format stuff, basically what we currently have, what is already there, and then build the missing low-level pieces and then go into those things. But basically it's on my to-do list to look what do we currently have, and I basically stopped at this serialization step, but now I move on to the other stuff. But
so some of the stuff I'm going to be really interested in when you get to it is, I have a feeling that you're going to discover most of the same stuff that I'm pulling my hair out right now about like this memory amortization stuff. And Rust is probably going to throw it in your face because it's Rust. And so I'm really excited to see how that shapes up.
Yeah.
Because it could have good lessons for me over here in another language, hopefully.
Yeah. So I'm still like I'm a bit I'm concerned that my Rust skills are not good enough to find the most optimal solution, but we'll see. So it's like I'm still discovering like the whole study stuff was certainly like a good step to learn, get deeper into stuff. So yeah, we'll see. It's amazing what Rust can do and like how many like you can do so many things in so many different ways. So I'm pretty excited to see like how we can get the IPLD stuff working. But that's cool. Cool.
So one more thing that I didn't write down, but I think we've talked about this a little bit before in some place or another, but we should put some more research points for all of us into recursion schemes and that sort of stuff. Because a much shorter way to describe some of my update this week is I basically discovered, oh, I want this data racker kind of abstraction for anamorphisms. And for almost any other kind of more complicated morphism, then I need a totally different abstraction that has different memory problems. It turns out that these memory amortization things are like completely isomorphic to the morphism categories, and that blew my mind and made it much easier to reason about everything that followed. And I have a feeling that that's just going to turn out to be like really reusable knowledge. So maybe we should put some thought into it in advance.
Yep. So yeah. So if you have any like or any good things to read or something, I'm happy to catch up. Or if I should just Google it and find whatever I find.
Yeah, I don't know any good resources. I'm like sort of getting it through osmosis from a bunch of like resources and some assembly required. I wish I had better links. If we find better links, that would be awesome.
Right. All right. Is there anything else? Nope. Okay. Then I close the meeting. Thanks everyone for watching or attending. See you all next week. Bye.